Hi, this is Chris, and in this video we are taking a look at questions 7 and 8 from section 3 of SAT Practice Test 3. So question 7 shows us this table of values for x and for f of x, and another way we can think of f of x, whenever you see f of x, it's really like just saying your y value. And the question reads, the function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? So believe it or not, this is not really as much a math question in terms of having to do calculations as this is really a terminology question. They're almost testing your vocab knowledge of a math term. Do you know what it means for something to be a factor of a polynomial or a factor of a function? And so that's going to be our important takeaway here. And I'll put this in red because it is very important. But when they say a factor, there's two ways we can think of that. We want to think that it divides in evenly, meaning with no remainder, or remainder of 0. And then the other way that we can think of it is if something is a factor, that means that the x value will result in a y value of 0. So all that means is that when you find the factor and you take that corresponding x value, then you would have a y value of 0. So since they give us a table of values, what we're going to do is we're going to focus just on that one value in the table where we see that y is 0. And here that corresponding x value is 4. So let's see what factor that would correspond to. Because notice, these are factors. This doesn't say x equals 2, x equals 3, x equals 4, x equals 5. It says x minus 2, x minus 3, x minus 4, and x minus 5. So just keep in mind that when you're actually solving these values, just like when you factor out a polynomial, picture it like this on your page, because I know you've seen this a bunch of times where you have a few different factors times each other, and we set it equal to 0, and we can set each one individually equal to 0. So that's really what we're doing here. So for this, for example, you can treat each one as if it says equals 0 to find that corresponding x value. And you could probably already tell that it's 4, but if you take a look at these x minus 2, minus 3, minus 4, minus 5 expressions, when you go to solve it as an equation, you add 2 to the other side. So this would give you x equals 2, x equals 3, and so forth. X equals 4, x equals 5. So that's how the factor corresponds to a particular value of x. And when we look at our table of values, we see that here when x equals 4, y equals 0, and that's our answer. So we wrote it out here and talked through it to make sure that we understand it, but you can see that this is a great example of a question where on test day, if you really understand the actual terminology, a lot of times that'll save you from having to do any sort of math calculation. This is really a question of terminology, and if we add that definition and understanding of what it means for something to be a factor of a polynomial to our toolbox, then this is a question we can get right, and get right very quickly under the time pressure of an SAT. Now let's take a look at question 8. So here they give us the equation of a line. It says y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point CD, where c is not equal to 0 and d is not equal to 0, what is the slope of the line in terms of c and d? So here we are given a point, and although we see some letters there, a lot of times we forget how to approach something because they show some variables where we might be more comfortable if we were to think about what to do if they had this with numbers. And a lot of times when people see coordinates, again, C and D looks a little confusing here, but just keep in mind any coordinate, whether inside the coordinate they have letters like C and D, or if they had numbers, it still all represents your x and your y values. Every coordinate is written as x comma y. And so if you ever have a coordinate given to you and the equation of a line in terms of x and y, I want our first instinct there to be to plug that in. So we're going to put a c in place of x, we're going to put a d in place of y, and we're just going to rewrite this equation. And so when we do that, we'll have d equals k times c plus 4. So that's step one, and that I want us to do instinctively anytime we see that. If they give you a coordinate and you see that you have an equation of a line with an x and a y, go ahead and plug whatever values you have for that coordinate in place of your x and y. And now the question's asking us, what is the slope of the line in terms of c and d? Well, hopefully, even though k is a different variable than what we sometimes see with the equation of a line, hopefully we can recognize that this is really just y equals mx plus b format. This is called our slope-intercept form. And if we see that this is slope-intercept, we know that when they ask for the slope, they're really just asking for the value of k. So we already have this equation set up, and now we just have to try to get k by itself. So to do that, we can subtract 4 from both sides. So that will give us d minus 4 equals k times c. And then we can divide both sides by c, and that will leave us with d minus 4 over c is equal to k. And that matches what we see in answer choice A. So again, for number 8, a couple things that we want to recognize. We want to recognize this slope-intercept form of a line so that we know the component parts that they're asking about. And then we want to recognize that when given a coordinate like this, we can always plug that in for x and y. You don't always get a numerical value. Sometimes you're replacing a variable with a different letter, but the process is always going to be the same. Up next, we'll jump into question number 9.